is a homework help video for the Ready, Set, Go problems for the lesson titled Leaping Lizards. In the Ready section, the directions ask you to use the Pythagorean theorem to find the missing side of each triangle. The Pythagorean theorem is a squared plus b squared equals c squared. Let's look at the example. The first thing we are going to do is to substitute the given side lengths from the triangle into the Pythagorean theorem. We need to make sure that we substitute the hypotenuse, which is the longest side, in for C, and the length of the given leg in for A or B. After the values have been substituted into the equation, I'm going to square 1 and 4, then work towards isolating B on one side of the equation. To do this, I'll subtract 1 on both sides of the equation, and then take the square root of both sides of the equation and get the answer as square root of 15. I want to leave my answer in the radical because this is the exact answer. If I were to convert this to a decimal number, then I would have to round the decimal number since this is an irrational number. In the set section, the directions ask students to transform point A on the coordinate plane. Let's look at the following examples. First, we're going to rotate point A 90 degrees clockwise about the origin. Point A is 4 units to the right of the origin and then 1 unit up. This means that to find point A prime, we need to go 4 units down from the origin and 1 unit to the right. The correct location for point A prime is 1, -4. I know that I have rotated 90 degrees because when I compare the longer two arrows that I drew, they make a right angle. Since these arrows meet at the origin, I can tell that I correctly rotated around the origin. If I compare the two shorter arrows, the second blue arrow has been turned 90 degrees clockwise when compared to the first red one. Drawing these arrows is an effective strategy for making sure that I perform each transformation correctly. In the second example, I am reflecting a point across the x-axis. When I reflect over a line, I need to see how far away my point is from the line, and then place point A double prime the same distance away from the line of reflection, but on the other side of it. For example, point A is 1 unit above the line of reflection. This means that point A double prime should be 1 unit below the line of reflection. So this means that point A double prime is located at 4, -1. To check to make sure that I answered this question correctly, I'm going to draw a segment connecting points A and A double prime, and then make sure that that segment that I drew is perpendicular to the line of reflection, and that the midpoint of the segment that I drew is on the line of reflection. With the third example, we are given a rule. There are values being subtracted from the x and y coordinates, which lets us know that we will be performing a translation. Subtracting 2 from the x moves point A 2 units left, and subtracting 5 from y moves the point down 5 units. A triple prime is located at the point 2, -4. With the Go problem, students are asked to graph linear equations and compare functions. To graph a linear equation, we need to first look at the structure of the equation. These equations are written in slope-intercept form, which means that we can easily look at the equation and find the slope and the y-intercept. And looking at question 9, the equation is f of x equals 2x minus 3. This means that -3 is the y-intercept and 2 is the slope. To graph this equation, it's easiest to start with the y-intercept and then use the slope to find our next point. This means we'll start with a point at 0, -3, and then go 2 units up and 1 unit over to the right to find our next point. Once we have 2 points, we can draw a line through the points. For question 10, I'll start by placing a point on the y-intercept, 0, -3, and then use the slope to go down 2 units and over 1 unit to the right to find my second point. Then I just need to draw a line through the points. To answer question 11, I can see that the two functions have the same y-intercept, but they have opposite slopes. In math class, when I use the word opposite, I mean that one is positive and the other is negative. Okay, that's it for this video. Thank you for watching.